Hello and welcome to the Equest training module. This particular module is on the design development wizard, getting into the screens for the project and site screens. Before we get started, I want to mention a few things. We have a poll with a few questions for you. It's located in the pie chart icon on your screen. So please weigh in before the end of the broadcast to answer those questions. And if you have any questions for me, please use the chat balloon icon to send me a message, and include your email address so I can get back to you afterwards. For links to resources, please visit the chain icons where you'll find a link to our feedback form and other helpful resources. The building that we're going to be modeling in this particular module is a multi-story office building with a basement with an attached warehouse. Now, we included all these features in the example building so that we can highlight a lot of the features of the program. The views are shown on the screen here. The warehouse part is the shorter section, and the office building is the taller one with the windows. Usually before I get into the program, I often get into the AutoCAD drawing and do some preparatory work on that so that it's easier to enter the information into Equest. Usually the AutoCAD drawing has many, many lines on it for the thickness of the walls and so on. Usually I'll get into the AutoCAD drawing and create a new layer where I just draw a single line, the outline that I want to input into the Equest. And I often usually once I have that line drawing, I often turn off the other layers or maybe even delete them so that it doesn't clutter up what I'm looking at in Equest. The floor plan for the example building that we're going to use is shown on your screen now. That's it for these PowerPoint slides. Now we'll get into Equest. To open up Equest, double-click on the icon that's on your desktop. And wait for this introductory screen. And we come up with this window that says Equest Startup Options. Now, when you have a project in here already, this first option will be available, Open a Recent Project. I deleted all the files that were in my directory before this so that it would clean it up. So nothing is shown here now. But you can click on the drop box, and it would show the list of the previous files that you've worked with in here. The second selection down here is select an existing project to open. When you click on this and say OK, then it'll go to the default project directory. And this is where your files will be located. Since there's nothing in there now, we'll cancel out of that. And actually what we want to do is start with the design development wizard. There are two different wizards within Equest. There's the schematic design wizard and the design development wizard. For this module, we're doing the design development wizard. So I click on that. And it brings us to these screens for project and site data. This first screen has general information. If you look down in the lower left corner, it says Wizard Screen 1 of 7. When I open that up, there's a screen 1 of 7 and a screen 3 and a screen 7. Now, the first question that comes to mind is, what happened to screen 2? What is screen 4 and 5? Now, the screens that are available depend on the selections that are made on this particular screen. We're going to get into some selections that will enable some of those other screens to pop up. The first field in here is called project name. And for our particular example, we'll enter a project name of class example dash whiz. I like to add a dash whiz at the end because when I get into the detailed interface, I like to create a separate file and save the information that I created in the wizard separately, because I may want to go back into the wizard and change some things. And it just makes it easier to keep a record of what was done in the wizards. Now, you can right-click on any field, and these different options pop up. There's Item Help, which will give you information about the particular field that you clicked in. This particular one is project name, and it gives some information about the project name. I'll X out of that. Right-click on this again. The second one down is called Topic Help. And when I click on that, that gives a list of all the different fields that are on this particular screen. So you don't have to click on the particular field that you're interested in. You can click on any other one and get to the fields on this screen by clicking on that second one down. Do it again, tutorials and reference. This is where you can access some of the references that come with Equest when it was downloaded. The first one is the glass library. The second is a tutorial. A third is details about lead analysis. And there's some information about lifecycle cost and modeling procedures, quick reference. We won't get into those at the moment, but I just want you to be aware that they are available by simply right-clicking on many of the fields. Now, this last one is restore default. It's not available on this particular one because there isn't a default. The next field over for code analysis has a few options. The program Equest was used primarily for showing code compliance with California Title 24, their energy code. And if that's the case, while you're using Equest, then you can select the California Title 24 or the savings by design. Now, this new feature that they have in the latest version of Equest is Lead NC. And if you click on that, you can see that another field appeared underneath it for what version of Lead. Lead 3.0 is the latest one, the one that was available when they created this option. And then you also notice that the jurisdiction in the field underneath it changed to ASHRAE 90.1 because that's the code that's applicable to Lead NC. Now, there have been some bugs with this particular feature. This doesn't do anything within the wizard itself. It simply enables certain screens when you get into the detailed interface where you can enter some information where the program can set up some of the default values for a lead model. We're not going to do that in our particular example, so let's change this back to none. For building type, there are several different building types available in here. There's healthcare, lodging, manufacturing, office, restaurants, retail, schools, storage. Now, these don't, selecting something here does not actually affect the calculations themselves within Equest. The selection here will determine what default values are put in place in future screens. So for our example, we're going to select office building mid-rise. Office building mid-rise. So it's right there. Now, you can go back to this field after you've gone into other screens, but you have to be careful. If you change this to something else, some of the default values in future fields will get overwritten. So if you progress a little farther along here and decide that another building type would actually be more appropriate for this, and you come back and change this, you might have to redo some of the things that you previously had done. Building location and jurisdiction. The location set. The choices here are California Title 24, all Equest locations, Canadian locations, and user selected. I typically do user selected, and then this field underneath it changes to weather file. And so within most of the fields within Equest, if you see the box with 3 dots next to it, you can click on that and access more information in there. So we'll do that, and that'll lead us to another screen where you can select the weather file. The default location for this is to go to the weather file, and I'm going to select Wisconsin-Madison Dane County Regional Airport for our particular example. Jurisdiction, I'm just going to keep that as other because I'm not going to use ASHRAE 90.1 or these California or Oregon or Washington, Seattle options. Just keep that as other. Utilities and rates. There are several different ways you can do this. Several predefined utility rates are available in here. Most of them are in the West, California, Oregon, Idaho. One option is a file. If you do work in the same utility service territory, and you use the same rates pretty frequently, you don't have to reinvent the wheel each time. You can save it as a file. And I'll show you that when we get to that point. But for now, we're going to select Custom. And we'll also do the same thing for gas. Now for the gas utility, select Custom. Now let's take another look at the wizard screens available at the bottom. When we first got in here, the only screens available were 1, 3, and 7. Well, now that we've selected a custom utility rate for both electric and gas, we now have screens available where we can enter the information for those custom utility and gas rates. Other data analysis here. This would be more appropriate if you're modeling an existing building where you're trying to match to utility data for a particular year. Something to keep in mind is that Equest and many other programs do not account for February 29th. So if you have a particular building where you're matching to utility data, which includes February 29th, you'll have to deal with that somehow because Equest does not have a February 29th. Usage details, there's only one option available for the DD wizard, so we'll just leave that as is. Then near the bottom, there's a checkbox for prevent duplicate model components. For people that are new to Equest, I suggest unchecking that. Checking that will reduce the file size somewhat, but it can make it harder to find a particular component if you're looking for it. So I often uncheck that to make it easier to find things. One of the things you notice as we're going through here is that some of the text is red and some of the text is green. Green text indicates a default value, and red is user selected. So when you change something from a default value to something else, the text will change from green to red. That's it for this particular screen. We can move on to the next screen by simply clicking on Next Screen, or we could jump ahead by looking at the drop box of the wizard screen. The next screen is 3 of 7, so let's select that. This is where we can select the schedules, or seasons for schedules. There's a screen later where we'll define the schedules, but here we'll tell the program how many seasons we're going to have. For example, with a school, you might have different occupancy during the summer than you do during the rest of the school year. And you may also have a different season for spring breaks or times when the staff is there and the students are not. So you can set up to 3 seasons in the DD wizard here. Let's click on Observed Holidays. This brings up a list of the different holidays that Equest can take into account. There's New Year's Day, or New Year's Day celebrated. If the holiday happens to be on Sunday and it's officially observed on the following Monday, Equest can take that into account. For our example, let's uncheck Columbus Day and check the Thanksgiving Friday. And we'll leave the other values as they are. And click on Done. Let's click on 3 to show the seasons that are available. We enter information about Season 2, when is Season 2, and when is Season 3. And the rest of the year is considered to be Season 1, which will have the typical use. Now, for our example, let's just have 2 seasons. And you notice that the fields for the 3rd season disappeared. A lot of times in Equest, when you see a blank area on a screen, it's often because the selections that were made just disabled the information that would otherwise appear in that part of the screen. Okay, for Season 2, how many periods are we going to have that will have this particular schedule? If you click on 3, you can see that now we have 3 different periods that we can define for that season. One of these might be summer. You could set up another as a spring break and set up another as a winter break. For our particular example, let's just have 1 season, and it'll be in the summer. So that's it for the season definition screen. Let's move on to the next screen, which is our electric utility rates. There are different ways that you can enter it. The simplest one is the uniform charges. We'll take a look at that first. With the uniform charges, you simply have a monthly rate and a simple rate for the kW demand and also for the kWh consumption. You can also define a second season here if the utility has different rates for different seasons. Now, this season is different than the season that we had on the previous screen, which defined the people occupancy. The season here is for the utility rate structure. Now let's select block charges. This particular screen enables you to enter different rates for different blocks, which could be based on a different kWh or kW-kWh combination. You would use this screen for ratchets. For our example, we're going to use the time of use charges. So click on that. We'll keep the second season here. For the customer charge, let's make that $20 per month. So enter a 20. Uniform charges, I'll keep those 0 because I'm going to have peak and off-peak rates. For on-peak, I click on that field, and let's use $7 per kW. And then right next to that is a field for dollars per kWh. And I click on it once, and the cursor does not go to that field yet. By clicking on another field, it's kind of like clicking, hitting enter. And you notice now that there's a box around the previous field that we were in. So I click on this field a second time. Now we get the box around it, and we can enter our number. And we'll enter a number of 0.1 for 10 cents a kWh. Now I'll scroll back over so that we can get to the kWh charge for off-peak. We'll keep that 0. Then the kWh during off-peak periods will be 5 cents a kWh, half as much. So 0.05. All right, our second season is defined from June 1st to August 31st, which is what we'll want. But to show you how to change it, if you click on the drop-down box, you get a calendar here. I can change that from June 1st to June 2nd. Or if I want to go to a different month, I can click on the left arrows to go to previous months, or on the right arrows to go to future months. Let's go back to June 1st. And for the customer charge, that's still $20 for the summer months. But our on-peak demand charge, if you click on the dollars per kW field, make that $10. Then I click over on the dollars per kWh. Let's make that 13 cents, the 0.13. Then we'll go down to the off-peak. I'll click on that field twice, and we'll make that 8 cents a kWh, so 0.08. Then I click on some other field so that it enters. Now that we have this set up, we can save it for future use. There's an icon in the upper right corner that looks like a computer desk. So I click on that, and it brings up the screen. The default directory for rates is in the Equest 3.64 data folder in the subfolder of rates. The type is EWR for the electric rate. And let's name this class electric rate. And click on Save, and it's saved. Okay. When we selected time of use rate, that enabled another screen, screen 5, which we didn't have before. That's not available because with the other utility rate types, because it's simply not applicable. So now let's go on to the electric utility time of use period screen. This is set up with the 2 seasons. Again, this is the utility rate season, not the people occupancy season. The radio buttons on the left side show which days will apply to the day type. For example, on day 1, we'll set up the on-peak times in a moment, but which days will have that particular schedule to it? The default is Monday through Friday will have a certain peak time, and Saturday, Sunday, holiday will have a different peak time schedule. And since that's pretty common, we'll leave that as it is. the timeline on the right side is for each of the hours of the day. The first box is from midnight to 1 a.m. The second is from 1 a.m. to 2 a.m. and so on. To change a particular hour block from off-peak to on-peak, you want to click on the orange box. And the way I look at this is your cursor is like a paintbrush. And I want to get the orange paint on my paintbrush. And now I can click on the boxes and change the color. You can click on them one at a time, or you can drag. And for our example, let's go out to 7 p.m. here on weekdays. Weekends and holidays, we'll keep it as an off-peak period. Then we do the same thing for season 2. I'll click on the orange box, and you notice that there's a little square around the orange box now, which indicates that that's the active color on the cursor, on my paintbrush, so to speak. And I drag across here, and that sets the peak time for the utility rates. Okay, onto the screen for the gas utility charges. One other thing back on here. If you want to change a color, if you accidentally went too far and you want to change it back to off-peak, you can simply click on the blue box, and you see how that square outlining it moved back there. Then I can click on these boxes, and they become blue again. Moving on to the screen for the fuel utility charges. This would be like for natural gas. We have the same sort of options here, except we don't have the time of use option available. There's the uniform charges and the block charges. And it's real similar to what we saw on the electric screens. We'll select the uniform charges. And for a customer charge, let's make that $25 a month. And for the uniform charges, let's make it $1 a therm. Let's create a second season. So click on the box for a second season. And we'll define that as April 1st. So click on the arrows to go back to April. And click on 1 for April 1st through September 30th. So click on the drop box here. Click the forward button to get to September and September 30th. So click on that. Now the customer charge, we'll keep at $25 a month. That doesn't change throughout the year. But during this summer season, instead of $1 a therm, let's say it's 80 cents a therm. So we'll enter 0.8 in that field. Again, we have the icon to save the file in the upper right-hand corner. So you can click on that. You can call it custom gas rate or some other file name. And notice that the extension is GWR for gas rate. Click on Save, and it is saved. Moving on to the next screen, that's project information. This is where you can enter the information about the address of the building, building owner. These don't affect any of the calculations. These just show up on some of the reports, if you'd like to have it show up on the report. We'll just leave it blank for our particular example to save time. Component name prefix and suffix. This is often useful if you want to combine information from different files. And this will give it a unique name. If the, these lower fields here, for a component to name prefix and suffix can be used to add a prefix or a suffix to everything that is in this particular project, this particular file. Now this can be useful when you're combining different files. And you may have components that have exactly the same name. And that can be a problem when you're combining the files. So to avoid that problem, you can have a prefix or a suffix for each of the things in this particular file. We're not going to be combining with another file, so we'll just leave this blank for now. So we're all done with everything in the project and sites data. So we can click the button to return to Navigator. Now, this Navigator has buttons where you can get to the different screens. We can go back to the project site utility by simply clicking on this top button up here. And it goes back to the project and site data screens. Now, it goes back to where you left off. The last time that we were in the project and site screens, we were at screen 7. So that's where it returns to. But you can simply go back to the other screens by navigating through this drop-down box or the previous screen and next screen. We'll return to the Navigator. And that's it for the little module on the project site utility screens. I'm gonna get a drink. Okay. Starting here in the Project Navigator, we now want to get into the building shell components, the information for the shell. Now, there are 3 different ways that you can get into it. One is to click on the button on the left side that says Edit Selected Building Shell. And it brings up the screens. I'll get out of that. I'll show you the other 2 ways. You can double-click on the particular shell. It'll take you to the same screen. And there's a 3rd way to get there. You highlighted it in the list here, and then click on Edit Selected Shell. So those are the 3 different ways that you can get to it. The shell name, let's change the shell name to Office Tower. And the building type, again, this will select the default values in future screens. Now, what's selected here is what we selected back in the project and site screen, that very first screen, the second field. So we'll keep this the way it is. When we have a future shell that's a different type, then we can select a different type of building for that. And then that'll fill in future screens with appropriate defaults for that. Let's check the box for Specify Exact Site Coordinates. I like to do this for when I'm tracing the building outline in AutoCAD, which we'll see in the next screen. This makes it easier to place other shells when you have multiple shells in a building. So make it Specify Exact Coordinates 0, 0, 0. Then for building area, for our example, we have about 90,000 square feet. Now, the building area for this particular field isn't used in any of the calculations. It's used to set up some of the things in the next screen, which we'll take a look at shortly. The number of floors above grade, let's change that to 5. And number of floors below grade, we'll make that 1. We'll leave the Use Floor Multipliers checked. This will reduce the amount of information that's stored in Equest, and it'll simplify the calculations. going further down on the screen, we have Shell Multiplier. This is useful if you have parts of the building that are identical to each other, and you just want to copy this shell. We'll leave that as 1. Daylighting controls. If there's any possibility that you're going to be looking at daylighting in your analysis, I recommend selecting yes here. Quite often when I do an energy model, I will want it off to start out with, but then turn it back on. And it's a lot easier to turn it back on if we have it set up in the wizard so that the daylighting controls are selected as yes. It's a lot easier to get it set up now than it is to set it up from scratch later in the detailed interface. Usage details, again, there's only one choice in the DD wizard. There's a second choice in the SD wizard, but we don't have that here. The component's name prefix, L1 is an abbreviation for shell 1. You could change the prefix to something else like office. But what I often do is just leave it as a default here, because if you copy information from a shell later on, it's also going to copy your prefixes here, and it can cause some problems. So I just leave that as the default value. You could also enter a suffix in here too, instead of a prefix. Now, the total number of characters that you have in your prefix and your suffix can't be any more than 4. You could have 4 characters in a prefix and none in a suffix, or you can have 2 and 2, you can have 3 and 1, but the limit is 4. So those are the fields in the general shell information. Move on to the next screen. We're going to spend quite a bit of time here. There's a lot of information to enter in here. And actually, before we get into this, I want to show you the 3D rendering of what Equest has for the building right now. So click on Return to Navigator in the lower right. Then click on Finish. Now the program will write some information to a text file. And we wait for that. Then it goes to this view of the 2D geometry. Right now, the way it's set up in Equest is our building, with the defaults that have been selected so far, is a square. And these lines within the square are how the thermal zones are divided up within the building. There's a big core space, and there's a separate thermal zone for each side of the building, north, south, east, and west. Now let's click on the tab on the top for 3D geometry. And that shows a 3D view. You see our 1 story in the basement, and there are 5 stories up above. Now, one thing that you immediately notice from this is that some of the floors are missing. Like, what happened to those? Now, when we check that box to do the floor multipliers for common floors, and to save computational time and memory space, Equest takes these missing floors to be identical to the other middle floor. So we have the basement at the bottom, and then there's the floor at ground level. There's the floor at the top. Then all the other floors in the middle are identical to the second floor that's above grade. We'll get into some more things in this view. Actually, I do want to do it now. Sometimes when you get into this 3D view, you can't see the picture. And there are a number of things that you can try to get the picture to show up. One is if you right-click on the black background, the first option there is Reset Camera. Usually selecting Reset Camera will make the image appear on here. If that still doesn't work, something else you can try is just click on any of the buttons across the top, any one of these, and then come back to Building Shell and click on 3D Geometry. Sometimes that's good enough to reset it. If that doesn't work, the next thing you can try is just running the simulation. Sometimes that'll make the image appear. If that doesn't work, another option is just to close Equest and reopen it again. And if all else fails, it reboots your computer. Within this 3D view, we can look around by holding down your Control key and then push down on your left mouse button. And while you're holding it down, you see that it's now a wire view instead of a solid view. It's just faster for the graphics program to draw it within a wire view. Then release on the left mouse button, and it stops at that view. So you can spin the building around, tip it up and down, take a look at whatever view you want. You can also zoom in and out by holding down your Control key again, but instead of the left mouse button, you hold down your right mouse button. Move your mouse down and it zooms in. Move your mouse up and it zooms out. If you want to look at the wireframe view of it, you can simply type W on your keyboard. Then you get a wireframe view. This can make it easier to see the zoning within a building. To go back to a solid view, simply type S. And one last thing in this view, if you type J, then Equest creates a JPEG file of this particular image, and it puts it in the project file, the same directory where you have this particular Equest file. Something to keep in mind with the view here is that it's not a rendering. It's a visual guide to help you to see how the information has been entered into Equest. You may see that a wall is off, a window's in the wrong location, or something like that. As we're entering information, we'll come back to this screen quite often to see if the information was entered the way that we intended. Okay, to get back into the wizard, we click on the Building Creation Wizard icon on the left side. So we'll click on that. It asks if you want to save it. Yes. Then it gives us warning up here, saying you're going into the wizard. If you were in the detailed interface and you made any changes, all of those changes will be lost. But we were never actually into the detailed interface, so there's nothing to lose. We were in this nebulous state where we weren't in the wizards and we weren't in the detailed interface, but we were able to look at the 3D view and some other things. But now we're really getting back into the wizard and get back to that project navigator and the other screens. So we'll click OK, and we're back to the project navigator. Within this 3D view, you can take a look at what surfaces are in this view by simply clicking any place on the picture. When I click here, it shows that we're going through the roof, we're also going through a ceiling, and going through a floor below it. if I click over here, it shows that we're going through a window, which is part of a wall, and below that it's going through a floor. And next below that is the ceiling on the floor above, and it goes through an internal wall, goes through another ceiling, and goes out a window, which is in a wall. So when you click on any place in here, it's like shooting an arrow through the entire building in this particular view. And it'll give you a list of all the components that you're shooting through. So that's a way that you can check some of the components on the inside. Okay, so that's it for the 3D viewer for now. Let's get back into the wizard. We'll click on the first icon on the left side called Building Creation Wizard. And it gives us this warning. Warning, you are entering the Building Creation Wizard. Any changes you made in the detailed interface may be lost if you press OK. Well, we weren't really in the detailed interface quite yet, so there aren't any changes to be lost. So we can simply click OK, and it brings us back to the wizard. We were in the building shell for the office tower. So you can double click on that, and it goes back to the screen where we left off. The footprint is the overall outline of the whole building itself. There are several shapes available for this. You can do a triangle. There's rectangle, trapezoid, L-shaped, T-shaped. You can see the list there. Rectangle with corners chopped off, or a corner chopped off, or custom. Let's keep it rectangle for now because I want to show you a few other features here. On the right side, the first field is building orientation. Plan north is up in the diagram on the left side. But if you want to change the orientation so that plan north is actually northwest, you can click on that. And you notice that the diagram of the building didn't change at all, but the north arrow in the lower right corner changed. Because that is true north. The north arrow is pointing to true north, and plan north remains the same. Now, I'm going to change that back to what we had before. And one way to do that is to right-click on it. And we saw these screens on the very first, or these options on the very first screen that we got into. So I click on Restore Default, and it changes back to north. When I click on one of the other fields, I see that the text is green now, indicating that it is the default value. It's not a user-entered value. The perimeter zone depth is how wide these perimeter zones are. I can change that to, say, 25 feet. And when I click on another field, notice what happens in the diagram on the left. It just makes the width of the perimeter zones 25 feet now. The aspect ratio is the shape of the rectangle, how stretched out it is. We can change the aspect ratio to 2 and then see what happens to the diagram. Now the X and Y numbers that show up here are calculated based on the information that we put in the previous screen. You may remember that we entered the square footage, we entered the number of stories. These values here are calculated from the total square footage divided by the number of stories to get the square footage per floor. And then for a rectangle with this entered aspect ratio, the dimensions are calculated to be 173.2 feet by 86.6 feet. The numbers down below here are for comparing the calculated value based on the dimensions that Equest has calculated to the area per floor that is calculated from the information that was entered on the previous screen. Now, there's sometimes a little bit of a difference just due to rounding. And we can see here that we're going to be off by 1 square foot. Not a big deal. Then the floor-to-floor height, we'll keep the floor-to-floor height as 13, but let's change the floor-to-ceiling height to 8 feet. Now, whenever the difference between the two is more than 1 foot, then Equest will assume that there is a plenum space in between the ceiling and the structure of the floor above. There are some options for entering a pitched roof here. When you check the box, there are a couple buttons that become available. One is for some simple inputs, and the second is for a custom roof footprint. We'll take a look at this in more detail when we get into the next shell. But for now, let's uncheck that. We'll change the building footprint to custom. So under footprint shape, click on the drop-down box, and the very bottom one is custom. And that brings up this screen where you can start with a previously defined footprint or a blank slate. The previously defined footprint is this rectangle that we've been looking at. But when I trace over a CAD drawing, I typically like to start with a blank slate. Now, when I check that, it comes up with these dimensions that will show up in the screen that's going to be coming up pretty soon. So we're going to have available 250 feet by 250 feet. If your particular shell outline is going to be smaller than that or larger than that, then you want to change the numbers here so that it'll all fit on the screen. But we're fine with 250, 250. So I'll change the CAD file to import CAD file. And I click OK, and we get this screen where we can navigate to it. And I want to go to here, navigate to wherever the CAD file is. This is it here. OK. Next we get a screen for what CAD units. Most of the time, the CAD drawing has one CAD unit of 1 inch. So I'll keep that the same. Drawing origin, I typically keep the default values on here because that'll make it simpler for when we do the next shell, and everything will line up nicely. So I click Apply and Close. Now, you see the outline of the footprint of the entire building in the background here. There are several different buttons in the upper left. We'll start with the second row, the second one down. The button on the far left is called View Properties. If you click on that, you'll get this screen of the different properties. There's the location of the origin and the total view. Show grid. The grid are those dots in the background. You can uncheck this and make them go away, but if you do any zooming or panning, they're going to reappear. So what I typically do is just keep them on there, but change the grid resolution so that it's fairly big and the dots are widely scattered. So let's make that 20 feet for the grid resolution. Then for snap ranges, this is how close your cursor has to be to that particular point for Equest to snap to it. Now for CAD vertices, I typically like to have it within about 2 feet. That's generally pretty good. and polygon vertices. Let's make that 1. Now, you can adjust these if you're not snapping to a point that you like. Sometimes if 2 points are really close together, it might not snap to the one that you want. Well, you can come back in here and change the snap ranges to something smaller so that it'll jump to the one that you're interested in instead of an adjacent one. Snap priority. The only thing that I want that I have here is the CAD. So I'll make that the first priority. Polygon, no snap, and grid. I'll change that to no snap also. So those are the polygon properties. I'll click Done. Okay, next let's get into the top row. This first button on the left is for drawing the vertices on the screen here. We won't do that quite yet. First I want to show you these buttons here. The magnifying glass is to zoom in and out. And you hold down your left mouse button, and if you move down, it'll zoom out. Move up, it'll zoom in. Let's get it about there. The next button is Pan. So we can move this over so that it's more centered. Right now we're just looking at the shell for the office tower. We'll do the warehouse part later. So now we've got that centered. I'll go back to Pan and zoom in a little bit so that it's like that. Okay. The white square with the D in it is for drawing mode. If you're looking at the particular CAD drawing and not on the screen on top where you're doing the vertices. Now, you have to be really careful when you're in here because if you zoom in and out, you're changing the scale of the drawing. So be careful not to do that. This next one is for opening a CAD drawing. If you want to have another CAD drawing in addition to the one that we already have, you can select the second CAD drawing. But we're not, so we'll hit Cancel. The book with the P on it are for properties of the CAD drawing. It gets us back to this screen with the units. We'll close out of that. And the next one is for the layers. The particular CAD drawing that I have just has one layer. But if you're dealing with a drawing that has many layers in it, and it's just really cluttered and it's hard to see what's going on, you can use this to turn off some of the layers so that it's not so cluttered. Okay, I want to unclick that drawing one because I don't want to accidentally zoom out and change the scale here. These other buttons in the second row are rather self-explanatory. The X is delete. This is undo, one of the best buttons ever invented on a computer, and redo. We want to start drawing the vertices here, so I'll click on the arrow on the right side there, and I'll start in the lower left corner. Just click on that. And as I move my cursor away, you see that it has a blue dot with a plus sign in the middle. That's our vertex. When I have my cursor in the screen area up here, down below the picture, it shows the coordinates of where your cursor is. The footprint status has one vertex so far, and there's no square feet, but with only one vertex. And some other information about the XY coordinates and angles. But when I click on that vertex again, notice that the color changes from blue to yellow. When the dot is yellow, then I can move it. See how I moved it to that corner there, and I'll move it back. When I click on it again and make it blue, then I can click and drag it to another corner to start tracing my outline of the footprint of the building. So to do that, I click and hold the left mouse button on this, and I move it over to another corner, and I release. Now, an important thing about tracing the footprint in here is that you have to go counterclockwise. So that's why I went around that way instead of the other way. If you happen to go around clockwise, when you finish, it'll give you an error, and you just have to start all over again. Okay, to complete our outline, I click and hold on that blue dot again, and I take it up to the next corner and release. And click and hold again, take it over to the next corner and release. So that's the footprint of our building. You can adjust some of the numbers or the coordinates of each of the vertices by simply typing the numbers in the table on the left side. Like, for example, if I want to make that 149 instead of 150, you see that it moves a little bit. One of the advantages of the DD Wizard compared to the detailed interface is that we have this graphical way of drawing the points around here. When you're in the detailed interface, you simply have this table of numbers of the vertices. And it can be a lot more complicated. It's more complex. You don't have the visual graphic to help you visualize that you're actually doing it right. Okay, so let's change this back to 150. Sometimes I change the numbers in here on the left side. If it didn't click exactly where I wanted it, it was off a little bit, then you can just refine the numbers in there. That's it for the footprint. So we'll click Done, and it'll take us back. You want to save it? Of course. I don't want to waste all that work that I just did. Now, we can get back into that by simply clicking on the button with the 3 dots next to that. It takes us back to the screen that we were just in. So click Done. The next thing we want to do is the zoning pattern within that footprint. Right now it's set up as perimeter core, but there are some other options. You can do 1 per floor, where there's no subdividing within the floor. There's by activity area. This is useful for if you define activity areas and on a future screen. For the zoning pattern, we're going to select Custom. It's the bottom one on the list. Again, we'll go with blank slate. And the background image is the same CAD file that we had before. So click on OK. And this is very similar to what we just saw with the building footprint. The difference now is we're tracing out the internal zones. Now, I start out by checking on the view properties. And I check the settings on here. Show grid at 20 feet, that's OK. Snap ranges, 1 foot should be OK. CAD, no snap. Actually, I want it to snap on that. So for CAD, select first. Polygon, no snap. Grid, no snap. And it should be all set there. So click Done. Then to create a new zone, we click on the button that says Create New Zone. Do that, then click on our arrow on the upper right here so that we can draw our dots on the diagram. And let's start in the lower left corner. I click there, and again we get a blue dot, just like we did for the building outline, the footprint. Click on it again, it turns yellow. Click on it again, it turns back to blue. When it's yellow, you can move it around. Okay, I click and hold on the blue dot, and I move it over to here. Release, and that creates a vertex at that point. Click and hold, move it up to the next point. Release. Again, we have to go counterclockwise. Okay, click and hold, release, and that zone's done. Now, create a new zone. Now, you notice the colors here. The yellow in the background indicates areas where there's no zone defined yet. The green is for a previously defined zone. And let's get started on this one here. I'll draw around here. And the area inside of that is blue. The blue is an indication of the current active zone, which the coordinates on the left side are for. You'll also notice that the vertices of the active zone are red, except for the one active vertex. Now, there are some limitations in here. Zones can only be so big. You can only have up to 120 vertices in a particular zone. And there are limitations on shapes, too. If you have a central courtyard, you have to essentially trace around it so that your zone is C-shaped. And you also can't do a figure 8. Within your CAD file, you also want to make sure that your lines have endpoints where you want to have it snap to. If there are, within your CAD file, if you have two intersecting lines and there's no endpoint there, then within this screen, the vertex is not going to snap to that point. It'll only snap to endpoints on the lines, not intersections. Okay, we'll keep tracing zones around here until we're done. Hit create a new zone. Go to the next one. Click a blue dot. Click and drag it over to the next one while going around counterclockwise. Up to the next, up to the next. And that's it for that one. Create a new zone. Click here, go around counterclockwise, up to here and over to there. That's it for that zone. Create a new zone. Click here, and notice that the next one I need to go to is off the screen. But if I just move the cursor over there, it'll automatically pan. And then down to the final corner there. Create a new zone. You can see how this could get really tedious if you have lots and lots of zones within a building. This is a fairly simple example, so it won't take us long. Create a new zone. Go with this here. Go around the rectangle. And our last one, create a new zone. I'll start up here, down to this corner, come around this internal zone. This will be our stairs, getting around the stairs. Up there. Okay, and that's all of our zones. Now, you can pan over by using the pan button, or you can use the scroll bar down at the bottom, too. Now notice if I click on this zone, then it turns blue. That's the active zones, and you can see the coordinates on the left side. To delete a particular zone, I could click on Delete Active Zone. I don't want to do that. I want to save all this work that I've done. So click Done. That's it for our zones. Now let's take a look at our 3D view again. We'll see how the building has changed. So we return to Navigator, click Finish. And it writes our text file. Now you see that in the 2D geometry view, it shows the footprint and the zoning pattern for our shell. That's exactly what we just traced out. When we go to the 3D geometry, we see that the building has the shape that we entered into it, and you can kind of see inside that it has the zoning pattern that we just entered. You can look around, see that it still has the windows all the way around. All right, so that's a good check. Let's get back into the building wizard. So click on Building Creation Wizard, click Yes. Has this warning, click OK. And let's get back into the shell, Office Tower. We can take a look at the zone names that Equest has assigned to each of these zones by selecting User Defined under Zone Names. Then you see that these names show up here. They're somewhat cryptic, but there's a method to the madness here. The first part of it is the prefix for the shell, L1. That indicates that this is part of shell 1. The next part indicates what part of the building this particular space is in. C is for core, like N is for north, E is for east, and so on. The next part indicates whether it's a space or a zone or a plenum. Then within the parentheses, the first part shows which floor it's on. The G is for ground, B is for basement, M is a mid-level, T is top, and ML is multi-level. For example, if you have an atrium or stairs. Now, you can change the names in here. If you click on a space, then you can edit the information in here. But some people have experienced problems if they change too many names in here. How many is too many? It depends on the file. So I recommend just leaving it alone here. And if you want to change the names of the spaces, wait till you get into the detailed interface. You can specify whether a particular zone is conditioned or unconditioned. Within our example, they're all going to be conditioned. Now, the multi-level space I'd like to use for our stair tower. Now, so I'll click on the space here for the stairs. And when I click multi-level space atrium, then it makes that a multi-level space. It'll go from the floor of that space all the way up to the top of the shell. So when you're dividing your building up into shells, you want to keep that in mind. If you have a stair or atrium that only goes part way up, you may want to cut off your shell there so that it will stop at the appropriate place. Okay, I'm going to change the zone names back to automatic. And the shades, the color of the particular zone is indicated by the key down on the bottom. The active zone has the red outline around it. The multi-level has the cross-hatching, which we just did for the stairs. The conditioned zones are all this dark gray. Any unconditioned zone will be light gray, and refrigerated zones will be the aqua color. So we're done here. We'll click on Done, and it takes us back to screen 2. Let's take a look at the 3D view again and see what happened when we made the stair tower a multiple space, or multiple floor space. So we'll return to Navigator, finish, and again I'll write that text file. Notice in the 2D view that the shading of the stairs is a little bit different, indicating that it's multiple floor space. Going to 3D geometry, the first thing you notice is that those missing floors are there again. When you have a multi-floor space, then in the 3D view it shows all the floors again. All right, let's get back into the wizard. Building creation wizard, save it, yes. Warning, okay. And back into the shell. So I'll double click on Office Tower, and it takes us back to where we left off. One other thing on this screen, I know there's a lot here on screen too, and it takes a while to get through it. But if you right-click on one of the exterior walls, there's a choice here of making a wall entirely adiabatic. Now, this is useful if you're building an addition onto an existing building. And this is the part where the addition is butting up against the existing building. You can just make the entire wall adiabatic. We won't do that in this case, though. And we're ready to move on to the next screen. Screen 3 is for the building envelopes. This is where we enter the information about the roofs, the walls, the floors, and below-grade walls and infiltration. We'll start with the roofs. There are different options here. You know, the nice thing about the wizard is it has these options that you can select that set up everything for you. If your construction happens to be one of these that's available here, wood frame, metal frame, various thicknesses of concrete, then you select one of those. The last one at the bottom, no exterior exposure or adiabatic, you would select this if there is going to be another shell on top of this particular shell. For our example, we'll select custom, layer by layer construction. And then under exterior finish color, we want to create new construction and apply only here. Then we get this new screen that comes up to give a name for it. Let's call it roof construction. And click OK. Now we get this screen where we can enter the different layers of our construction. Okay. We'll keep the name the same. We can change the name here if we want to, but I'll keep it the same. For the surface type, it's going to be a roof, so we'll select the roof. Now the layers that we enter here are from the outside to the inside. We don't enter anything for the film coefficient on the outside layer, because that's going to be calculated by the program based on the wind speed that's in the weather file for each hour of the year, and based on the roughness of the surface of this first layer that we enter in here. The spec method, you can either pick something out of the library or specify resistance only. The specify resistance only is rather convenient, but it has the drawback of it won't account for the thermal mass and the thermal lag that occurs because of that. And when you're doing a model that has to follow the rules according to Appendix G of ASHRAE 90.1, the specify resistance only is not allowed. You need to use a method that takes into account the thermal lags. So we'll keep that library entry. And for our category, we're going to select built-up roofing. Now, the materials in the list here are in alphabetical order, except for the insulation layers. which are listed separately in their own alphabetical order down at the bottom of the list. An air layer is considered an insulating layer. So our first layer is going to be the built-up roofing. And we'll keep the default thickness in there. For the next layer, we'll select another library entry. And for the category, scroll down to the bottom for the list of insulation layers, and we'll select polystyrene. And among the choices for the polystyrene, we'll pick expanded and 3 inches. Now, I want the insulation, or the R value for this insulation layer to be R15. So we can play around with the thickness here. We can't specify the R value within the wizard. We can only specify the thickness. So I click on that field, and if I have a thickness of 0.278 inches, and I click on a different field, that'll give us an overall R value of a little bit over 15. All right, for the next layer, we're looking at another library entry. It's going to be steel siding. You have the insulation sitting on top of a steel deck. So we'll select steel siding, and aluminum or steel thickness is fine as is. In our last layer, library entry, this is going to be our inside film coefficient. And that's considered an insulating layer, so we scroll down to the list of insulating materials, and surface air film. It's the next to the last one on the list. And the type is inside surface film. Since it's for roof, we want to select the very bottom one, horizontal roofs. And we click Done. Those are our layer-by-layer constructions for our roof. Next, we want to do the walls. The different types of wall constructions available include various wood frames, metal frames, and stress skin, concrete, CMU, or you could do the layer-by-layer construction like we just did for the roof. If any of the walls are going to be frame walls, I suggest entering the frame wall here in the wizard, because when you get into the detailed interface, it will account for the thermal bridging of the studs within the frame wall. So we're going to select metal frame, 2x6, 24 inches on center. For the exterior finish, let's select brick. And its color is red masonry, that's fine. Exterior insulation, this is in addition to what's in the cavity in the frame structure. This is continuous insulation, and it's outside. Let's select that to be at 2 inches of polystyrene. And additional insulation, make that none. And more interior insulation, we'll keep that at none also. So we have our cavity insulation between the frames, and the exterior insulation of 2 inches of polystyrene. And that's our wall. For the ground floor, now this isn't the basement. This is the first floor that's above grade, that's touching the ground. And the exposure here is earth contact. This takes into account the conduction at the very bottom of the wall where it's in contact with the ground, and heat is conducting out through the ground. The choices here are earth contact or over a parking garage. We'll leave that as earth contact. For the interior finish, We can have carpet with various padding, or vinyl tile, or ceramic and stone. We'll leave that as carpet. For the construction, the slab is 6 inches of concrete. And for the insulation, there are different choices here. You can have horizontal or vertical insulation. It can be on the interior or exterior of the foundation wall, in various thicknesses and various depths. We'll leave that no perimeter insulation here. Now for the below grade walls, we have limits on the construction types available here. Various thicknesses of concrete, wood framing with various frame sizes. We'll leave this as 6 inches of concrete. And for insulation, let's add a layer of external board that's R10 and goes down 4 feet deep. So that's our below grade wall insulation. The last thing on this screen is infiltration. And there are a couple different methods available here. If you click on this button, it opens up this other screen for us. We can specify whether it's in CFM per square foot of wall area, CFM per square foot of floor area, or air changes per hour. Now, the methodology selected here has an effect on whether wind is taken into account. When the air changes per hour method is selected, it will account for the wind speed. But if you're doing one of the CFM per square foot methods, it will not take into account the exterior wind speed. The default values that they have in here for the perimeter zones is for curtain wall. For an opaque wall, there's not a lot of research available on this, but a common value that we've seen on this is 0.15 CFM per square foot of exterior wall area. So let's enter 0.15. And for the core zones, we'll leave a little bit in there. That'll account for roof penetrations and leakiness to that. So we'll click Done. And that's it for the screen on building envelope constructions. This next screen is on building interiors construction. Now, they don't play a big role in the energy consumption of a building, unless it's more relevant if you have conduction, heat conduction through a particular wall. Like, say if it's cooled on one side but not on the other side, and you'll have thermal conduction through it, then the wall construction is really important. But if you're going to have the same temperature on both sides, and there's no heat conduction through it, then it's not as critical to get the wall construction. Unless maybe you want to account for the mass of the wall. If you're taking advantage of passive solar thermal storage and a sun patch is going to be beating on this wall, then you may want to take into account the thermal mass of the wall. For the ceiling types, you could have a lay-in acoustic tile ceiling, drywall, or plaster. We'll keep it the lay-in acoustic type with no insulation sitting on top of it. There are options to add some various R values of insulation. For the vertical walls, you have choices between air, which is essentially none, a frame wall, or a mass wall. The air walls will not have any thermal lag to it. The frame wall is assumed to be a 2x4 with metal studs. And the mass wall is a 6-inch CMU with filled cores, insulated cores. So we'll keep that a frame wall with no additional insulation. Again, you have some options for adding insulation to it. with the floors, you have carpet, 4-inch. You have choices of carpet, vinyl tile, or stone, or no surface finish. We'll keep the carpet in here because this is our office part of the building. For construction, various thicknesses of concrete or some plywood. We'll keep that 4 inches of concrete. And you could have a concrete cap. And you could add insulation to the floor slabs too. For our particular example, we won't. But this will be useful for if, say, the floor below is not conditioned, or then you'd want some insulation in there. Slab penetrates wall plane takes into account where the floor slab extends out beyond the wall. Sometimes you see this in a two-story motel, where the second story has a balcony, and the floor for the balcony is a part of the floor of that second floor, and it just goes straight through the wall. So there's no wall insulation there. And by checking this, the program will take into account that break in thermal conductivity at that point. We'll leave that unchecked. So that's it for the screen on building interior constructions. This is for exterior doors. Now, if the exterior doors don't have a lot of area within your particular building, you might be able to neglect it. When following the rules for the energy modeling of Appendix G of ASHRAE 90.1, you're allowed to neglect parts of the exterior wall that are less than 5% of the overall wall area. And your doors might fall into that category. So you may want to keep that in mind. But for our example, we'll select an opaque door. The different types available are opaque, overhead, glass, a sliding atrium, glass, airlock entry, which is also glass, and a revolving door with glass. We'll start with opaque. So we'll select opaque. And now we have the number of doors for each side that we have here. We'll want none on the south and none on the north. And we'll keep one on the east and one on the west. Now we'll select another door type. This time we'll do glass. And we'll put this in the front. There'll be one on the south, but none on the others. So we'll keep one under south and then zeros in the other categories here. Now, if you want to delete one of these, you could just go under, for the bottom one, just go select another. Then it'll disappear. That's how you would delete one here. Let's go back to glass. And we got one on the south side. Okay. These fields in the lower half of the screen define the size of the door and what the door is made out of. This door type 1, our opaque door, will be 7 feet high but only 3 feet wide. So we'll change the width from 6 to 3. And for the construction, let's select steel with a polyurethane core with a thermal break. For the next one, the type 2 door, which is our glass door, which we'll have at the front entrance, 7 by 6 is fine. Now, when you have a double door, you don't necessarily have to enter it as two separate doors. You can enter it as one single door if you like. That can simplify things. And there are different types of glazing that you can select here. You can specify the properties, which we will do. We can import the data from a program called Window 5, which is available from Lawrence Berkeley National Laboratory. It can be an unglazed opening. Just leave it wide open and let the breeze blow through. There are various single glaze options, double glaze, triple glaze, and even a quadruple. And for each of these types, like for the single clear tint, There's single clear, or single bronze, or single green, various thicknesses. Now, the numbers in parentheses here refer to numbers that are in the glass library. Now, if you right-click on here and go under Tutorials and Reference, remember, one of the options here is the DOE Glass Library. I can select that, and it brings up a spreadsheet which has a list of all the glass types that are available here. And this column C, the glass codes type, is that 4-digit number that you see in the parentheses there. So I'll close out of this. And instead of selecting a type from the library, I'm going to select Specify Properties. And notice that the button changes. There's no longer a library entry that we can select from. We need to enter the properties. So you click on that button, and it takes us to another screen. And here is where we can enter the properties of the particular window. Now, there are a couple methods to do it here. There's the U-value or the NFRC U-factor. When you do it with the U-factor, then the numbers that you have in here will include the frame effects. If you just do U-value, it is just for the glass values, and you have to enter separate information about the frames. We'll select the U-value. And you notice that the units for the solar transmission changed. With the U-value, it's shading coefficient. With the U-factor, is the solar heat gain coefficient. So be very careful about which solar units you get and enter into here, because it's different depending on the methodology that's selected. Let's go back to U-value. And these fields in the middle enable you to select different types of windows. And by selecting this, the numbers for the U-values, shading coefficient, visible transmittance, will change down below. So maybe you know some of the characteristics of the window, but don't know the numbers. You can use these screens here to narrow down the characteristics, and it will find a glass that's find values for glass that are appropriate for the values that you've selected. We're going to actually enter the values, though. For the U-value, we have 0.57. For the shading coefficient, it's 0.45. And for our visible transmittance, we'll make it 0.6. So U-value 0.57, shading coefficient 0.45, visible transmittance 0.6. And I'll click Done. Now, since we've selected U-value, we still need to enter information about the frame. The default value is aluminum frame without a thermal break. I want to change that to aluminum with a thermal break. And frame width of 3 inches is fine. All right, well, let's go check out the 3D view, see what happened here. So return to Navigator, and at the Project Navigator, click Finish. It'll write our text file. We should see 2 opaque doors, one on the east side, one on the west side, and our glass door on the south side. So click on the 3D geometry. There's an opaque door on the east side. It's that brown color. And then the glass door is put right here. Now, when the wizard locates these doors, it puts it in the middle of the first zone from the left corner. So that's why our glass door is showing up in the middle of that zone instead of the middle of the main entry, which is in the middle of the building. So we're going to have to move that when we get a little farther along. Here's our opaque door on the west side. And as we pan around to the north side, there shouldn't be any doors. Looks good. Let's get back to the wizard. Click on Building Creation Wizard. Save it, yes. Warning, OK. Double click on Office Tower, and it takes us back to where we left off. So that's it for exterior doors. Now we'll take a look at the next screen, which is exterior windows. Now, we'll see a lot of similarities that we just did for the glass door here. The first thing you see here is you can enter the percent of wall area for the windows. You don't have to enter individual windows. You can just enter the percentage on each face of the building. Now, the percentage can either be based on the net wall area or the gross wall area. The difference is the gross wall area includes the wall of the plenum. The net wall area is just the wall area below the ceiling and does not include the plenum wall area. We'll keep it net wall area for here. And we start out with two different window types. The reason there are two in here is because in the California code, there are requirements for north-facing windows that are different than windows that face other directions. And the defaults are set up for that. For the first glass type, we're going to select double low E. So find double low E in the list. Select that. Then we have several choices here for the glass type double low E. We'll keep it the very top one, the 2600. And for the frame type, we'll select the aluminum frame with a thermal break with a fixed insulated spacer. And keep the frame width of 1.3 inches. That's fine. Now for glass type number 2, we're going to do the same glass, but enter it a different way. We're going to do it by selecting the properties. So click on the drop-down menu. You have to scroll up to the top, and the second one down is Specify Properties. Select that. The drop-down menu to the right of that changes to a button, so click on that, and we can enter the information here. And I want to enter the U factor values. And notice that now it's the solar heat gain coefficient instead of the shading coefficient for the solar properties. And when you look at that number or that glass type in that spreadsheet, the glass library, actually, let's go back to that. Right-click on any of the fields, go to Tutorials and Reference, and then go to Glass Library. It brings up the spreadsheet. And look in here for 2600. Here's 2600, and I see that the U value with the frame is 0.63, and the other properties are in here too. I'll close out of this. Okay, click on the button to get back into here to enter the properties. The U factor was 0.63. And the shading coefficient was 0.72. I'm sorry, solar heat gain coefficient, not shading coefficient. And the visible transmittance is 0.77. Okay, so these numbers match what we had entered for that first glass type. But we'll see later on how that makes a difference in the way that Equest does things. One difference in what Equest does is when you enter the U factor or U value, it will not take into account the angle of the sun shining in on the window. It assumes that the light beam is coming in normal. It has the normal properties. Or normal also meaning perpendicular to the glass. When you enter something from the library, it will take into account the angle that the solar beam is hitting the glass. And that can make a significant difference. You can do a test run yourself by just changing the way that the glass type is entered in here and seeing what the difference is. Okay, for this third type, we're also going to specify the properties. One thing to notice on type number 2 is that since we use the U-factor method, the frame width is 0. Because with the U-factor, we're already taking into account the thermal conduction effects of the frame. So Equest knew to make the frame 0. For this third glass type, we'll also do specify properties, but we'll use the other method, the U-value method, rather than the U-factor method. And for that, we'll enter the values are 0.63 for the U value. For the shading coefficient, it's 0.84. And the visible transmittance is still 0.77. Click Done. And notice that we still have the frame width here. So we're doing it a different way here. We have just the glass values, the glass U value, and we also have the frame, the thermal conductivity. So these are the three basic ways that you can enter the information for a window in Equest. This lower half here is a way of indicating which or how much of each type to put on each face and of what size. With the window width, let's make the window 20 feet wide. Then I'll click on some other field. And you'll notice that this checkbox came up here. This checkbox has different meanings in here. Well, when the width is 0, like when we started out here, then the program will take a look at the percent window to wall ratio and make that exact. It will make the width, adjust the width to whatever is needed to make that window to wall ratio work out exactly. By entering a width in here, we have a couple different options. You can either make the program stick with only windows of this particular width, and the window to wall ratio will be off a little bit, or you can make the program add a little shorter window in there so that the window to wall ratio works out exactly. Now, when you check the box, that means that you keep the width. You don't have that extra smaller window to meet the window to wall ratio. So we're going to uncheck the box and say that the window has a height of 6 feet and a width of 2 feet. Now, when I click Tab to go to the next field here, we got this error because the way it's currently entered here, we have 62.5% of the north wall with this window type. And it simply can't fit a window of that size in there yet. Well, we haven't adjusted the sill height yet. So I'll click OK. Change the sill height down to 2 feet so that we have an extra foot available. And then it's fine. This window type 1 we want on the north side, but we'll make it 30%. Okay, we'll do the same thing for the other window types. We have a width of 20 feet, height of 6 feet. And again, we get that error, but I'm going to change that to 2 feet. And we'll put this on the east and west sides, again with 30%. And none on the south side, so I'll change that to 0. And uncheck the box. And for window type 3, again, we'll make it 20 feet. And I'm going to make the sill height 2 feet and make the window height 6 feet. And we'll put that on the south side. So 30% window to wall ratio on the south side. Then one other thing, I want to change the frame type for window type 3 to the same as what we had for window type 1. Aluminum break, fixed insulated spacer. And that matches. We'll leave this window type 3 on the south side checked. And then we'll see that for that particular face, we will only have windows that are 20 feet. We will not have the additional smaller window to make up the difference to get the window to wall ratio right. So let's return to Navigator. Click Finish. It'll write it the BDL file. Take a look at the 3D view. And sure enough, we see on the south side, and we have these 20-foot windows. And there aren't any in this middle zone here because it simply doesn't fit. And if we scroll around, we see on the other sides that it puts in as many 20-foot windows as it can, but then it also includes a smaller window so that it gets the window to wall ratio to match what was entered. Okay, let's return to the wizard. Yes to save it. Warning, OK. Double click on the shell. Now, I'm going to uncheck that so that it gets them the same size. It should be 6 and 6. Now, we can change the windows by clicking on the custom window door placement. So we'll click on that. And it comes up with this warning because any changes that we make in here will go away if we ever go back to our zones and make any changes to our zones. You remember earlier we were tracing around our AutoCAD drawing with those different points. If we go back and make any changes there, or change the footprint type, or change the way that the footprint or the zone is done, any changes that we make here will disappear. So be very careful before you go into this. And actually, we will wait to actually make any changes until we're done with the other shell. But for now, we'll take a look at it. Let's still get in here. And this view in the upper left shows this section of the wall on the ground floor. The red line is which wall you're looking at. Across the bottom is an elevation view of that particular section of wall as looking at it from the outside. If you were standing outside looking at the wall that's highlighted in red, this is what you would see. And the window that's highlighted in red is the selected window, and its information is shown in the upper part, up in this area here. I can click on this one here, and you see the values change. Click on this one, and you see the values change again. The X and Y coordinates are the location of the lower left corner of the window from the lower left corner of the wall. So an X of 9.75 feet means that the lower left corner of this window is 9.75 feet to the right of the lower left corner of the wall. And it is up 2 feet. The dimensions of the window are 15.75 feet by 6 feet, and it has a frame width of 1.3 inches. The glass type is what was selected. You can change it here if you want to. If this one particular window is different, this is how we can change it. And you can also create and delete new doors and windows. We'll get into this later in the other shell, but I wanted to give you an overview of what it looks like in here. You can click on another section of the wall, and it shows this one window on that particular section of wall. Go around to the north side, you see these windows. Now these are all on the ground floor. If you look at the buttons across the top, there's ground, mid, and top. You can have different window arrangements based on whether it's on the ground floor, one of the middle floors, or on the top floor. For example, on the top floor, the windows on this side look like this. Now, one of the differences on the ground floor is you also see the doors. So let's get out of here. You can click Done, and that's it for this screen on exterior windows. The next screen is for window shades, blinds, and drapes. There are two different types. There's the overhang, which goes at the top of the window, and then there are fins that go on the sides of the windows. For the overhangs, you can have it on none, of course, or you can put it on the top floors only or on all windows. We'll select all windows. And the distance from the window, this is how far above the top of the window the overhang starts to stick out. So if it's right at the top, your distance will be 0. If it's below the top of the window, and you have some of the window that's above the shade, then the number in here would be negative. But we'll put it 2 feet above the window. That way in the winter time, when we want the sun to shine in, then the shadow is falling on the opaque part of the wall and not on the transparent window. So it's above 2 feet, and we'll just put it on the south side and have it stick out 4 feet. Now with fins, we'll put those on all windows on the east and west sides, and we'll have them stick out 4 feet. And keep its distance from the window at 0, so that's right at the edge. Now, this is another reason to have different window types. If you're going to do the shading differently on different types, then you may want to enter it as different window types in the window screen. Even though they may be identical, and you enter the properties identically, if they're entered differently, then you can split it up here and have a different shading technique. So on the south side, we're just going to do the overhang. Window type 1 is on the north side, so we won't have any overhangs or any fins. So we can uncheck those boxes. Window type 2 is on the east and west sides, so we want the fins there. We'll keep that box checked, but then we'll uncheck the overhang. And window type 3 was on the south side, and we want that to have the overhang, but not the fins. So we'll uncheck has fins. Windows, blinds, and drapes, these are for interior shading. And there are different types available here. You can do the horizontal blinds of different colors, vertical blinds, shades, drapes. Now, when you select one of these, what happens is Equest sets up a transparency schedule for the particular windows. And then you can take a look at those schedules when you get into the detailed interface. But for our example, we'll leave that none. Right, that's it for this screen. But let's take a look at the 3D view again, since we're changing some things that show up on the 3D view. I like to go back and check and make sure that it's the way that I intended. Okay, take a look at the 3D view. We got the fins on the sides of our east windows, nothing on the north windows, fins on the west windows, and the overhangs on our south windows. So it looks good. Okay, back to the wizard. Save changes, yes. Warning, okay. And get back into the shell component. Now, one of the restrictions of Equest is that the overhang has to be rectangular, and it's completely opaque. Now, when you get into the detailed interface, you can change the transparency of the overhangs. When a window blind or drape is selected, it may be partly open or partly closed, depending on the schedule. You can modify that in the schedule that's created. And it may reflect light backwards out of the window, or it can transmit light through it. And they improve the window U value, and not just affect the shading. It also affects the overall U value of the assembly. Okay. Now we're going to change the depths of the fins and overhangs back to 0. So it's essentially taking them away, but then later on, I want to see the effect of adding them. So for now, I want to get them in, essentially take them out, so that I can put them back in again. In some cases where you do this technique within Equest, put something in, then take it out so you can put it back in again. When you take it out, you might not be able to make the value exactly 0. You can with these shade depths, but there are some other instances where you cannot. And in a case like that, you can just make it as small as you can, like 0.001, and then it's essentially negligible. All right, let's move on to the next screen. Roof skylights. We're not going to do any skylights in this particular shell. We will in the next shell, though, and we'll cover that a bit later. Next screen is daylighting. This is being able to control the lights, turn them off or dim them when there's sufficient light coming into the windows. There are different methodologies. The daylight area method, there are two for California Title 24. There's a newer one for 2008 and an older one for the 2001 and 05 versions. There's also a simplified version that's only available in the wizard. But in most cases, I need to get into the detailed interface for something to modify something that the wizards just don't take care of. So I stay away from that. I typically use the California Title 24, the 2008 one. So I'll select that. The design light level, the default is 50-foot candles. Let's knock that down to 30. And for our control scheme, there are all sorts of dimming strategies. They're switched depending on the type of lights that you have. Let's do switched, full 2/3, 1/3 off. And this diagram on the right shows which spaces will be daylit. it has this dark green color. You can click on a space, and then it'll become a non-daylit. It goes to gray. And these red dots with the yellow outline around it is the location of the photo sensor for that particular space. Now, you notice that when I clicked on this zone up here to remove daylighting from it, the selection on the top changed from side lighting to custom. Well, I'll change that back. I could click on this, and it'll still be custom because it knows that I made a change, even though I changed it back. But I'll just click on side lighting, so that it'll retain all the default things for that. Now, notice that this is for the ground floor daylight zoning. If we go on to the next screen, this looks very similar, but this is for the middle floors. And the default values here are whatever we selected on the previous one. So we can change it, but it works out pretty nicely to have it copy the first one that we did. Then we'll move on to the next screen, which will be the top floor, and we have the exact same things. We'll keep the same settings here. That's it for our daylighting screens. On to the next screen, which is our building operating schedule. You may remember when we first started out, there was a screen early on that talked about the different seasons, identifying a summer season and so on. This is where we set up the schedules for those particular seasons. Season 1 here was for the non-summer. The use that you have in here is, well, it could be totally closed, which will have no people in it for those periods. You have low use, typical use, or high use. These will affect the people density patterns in the schedules, which we'll take a look at later. But we'll keep it typical use for now. And 8 to 5, Monday through Friday, and closed Saturday, Sunday, holiday is fine. You can change the time by simply clicking on the drop box and selecting the appropriate time. You could have it open 24 hours, closed all the time, midnight or some other time. Then same sort of thing for the season 2. For season 2, let's just pick that for low use. There just aren't quite as many people there, but they're there at the same times. So we'll keep the times the same. Now, while you're setting up the schedule, it seems to be all or nothing. It appears that there's nobody there until 8 a.m., and then suddenly everybody's there until 5 p.m., and then suddenly there's nobody there again. When we take a look at the schedule profiles, we'll see that that's not the case. Let's move on to the next screen. Activity areas allocation. This is basically the place where you can enter the people density and the ventilation rates for the different space types. And we will later be assigning thermal zones to these. But first, I want to take a look at the schedules. If you look at the bottom, if you click on the 3 dots on the far right side, that'll take us to this viewer that shows the schedule profiles. Now, what we see here is the schedule profile for Monday. And you see that at 7 o'clock, a few people are coming in. At 8 o'clock, most people are there, but not everybody. But then by 9 o'clock, everybody's there. Then people go out for lunch, come back for the afternoon. Then it starts dropping off in the early evening, and you have some stragglers that go into the night. Now, within the wizards, you can change this a little bit, but it's limited. You can change the peak. Right now it's set at 90%, we can change that to 100%. Now, after you enter a number in here, don't hit enter because it'll take you back to the previous screen. It'd be like clicking on done in the lower right corner. So you want to click on one of the other numbers. So I click on that, and then you see how the shape changed so that the maximum is now at 100% instead of 90%. I could also change it so that it's down at 50%. Let's click on some other number. And it goes down to that. We could also change the minimum. Suppose there are some people that are there all night long. Maybe it's 10% of the maximum. So we can enter number 10 there. So that's how we can adjust the maximum and minimum you see here. You can also change the entry and exit times for the people in here. And the way it's done is you don't actually enter the time in here, but you enter the relative number of hours from this starting point. So if you want to move it an hour earlier, you would type in a -1. Then click on some other number, then it shifts over 1. If you want to move it to a later time, then you make it a positive number. I'll make this a +2. Then you see that it shifts over. So within the wizard, you can adjust these schedule profiles, but you're limited to stretching and squishing in both the horizontal and vertical directions. You can't change the essential shape of the load profile. Now the changes that we made here were just for Monday. You can click on this one on the top, and you can do the same thing. And for Wednesday, Thursday, Friday, Saturday, I have a cooling design and heating design. For the heating design, there aren't any people in there, which is pretty typical. Now, let's change this back to where we were. 0, 0, now it's 90, and 0. OK, that was for Season 1. We can see what it was for Season 2 by selecting that in the list on the left side. And now you can see that the maximum was 67.5 instead of 90. That's a result of selecting low use in that previous screen instead of normal use. This olive-colored outline that you see in the background is for the other season. Now, we also saw that when we were looking at Season 1. The olive-colored line is what the profile is for Season 2. Okay, that's it for looking at the schedule profiles. Now the activity areas. Okay. We'll keep an office plan, and we'll make that 50% of the area. So let's change that to 50. And for the square foot per person, we'll keep that 200, but we'll change the CFM per person to 17. That's the number that comes from ASHRAE 62 to account for the ventilation for the people and for the area, too, the blended rate. Within this version of Equest, you can only enter ventilation on a per person basis, not per area. So to account for the area component of the ventilation from ASHRAE 62, you need to take the combined value so that it's on a per person basis. Now, these checkboxes on the right will tell the program how to allocate these different areas within the building. Like, for example, will most of the offices be below ground, or on the first floor, on the middle, or on the top floor? And also, within these floors, is it more likely to be in the core or on the perimeter? Now, we actually traced the the different zones. So we're going to do it room by room. But if you were really early in design and you didn't have the room outline within the building floor plan, you could use this to help allocate the different space types within the floors. Okay, for area type number 2, we're going to make that a conference room. These are in alphabetical order, so let's scroll up into the C's, select a conference room, and we'll keep that 30%. For the people density, let's make it 20 square foot per person and 6 CFM per person. Okay, corridor, okay, we'll keep that 10%. And to get the ventilation value here, the ventilation rate is 0.06 CFM per square foot. And so what I want to do here is enter a 6 in here, then enter 100 in here for the square foot per person. And this will give us our 0.06 CFM per square foot. Next we have a lobby. That's fine, but I want the ventilation rate to be 11 CFM per person. And then for space type number 5, we'll make that storage, conditioned, 5%, and the ventilation requirement for that is 0.12 CFM per square foot. So we'll do a similar thing to what we did in the corridors. So I'll enter 12 in here and 100 in here. And that'll give us the 0.12 CFM per square foot. It'll also give us some people, which is acceptable. If you want to have fewer people in here, you could add a 0 to this. You'll make it 1,000 square foot per person. But then you would also need to change the ventilation number here to 120 per person, because we have 1/10 as many people, so we need 10 times as much ventilation per person. Okay, these are all the space types that we're going to have, so I want to get rid of these others. I'll do that by select another. That goes away. Scroll up to the top, select another, goes away. Scroll up to the top, select another, and we're down to our 5. Now, the percent areas has to add up to 100. You'll get an error if you get less than that. But I adjusted the office area so that that's 50, and it adds up to 100. Now, if you're going to follow the percent area here real closely and use the checkboxes in here to have Equest define the area allocations, you don't need to show this group screen here. It'll just take care of itself. But since we're starting out with the zones already defined the way I want them, I want to show this group screen. So keep that checked and on to the next screen. And this is where we can enter the area type for the particular spaces. Now we'll get into the zone group definition screen. Now, in some cases, this might be easier to just take care of when you get into the detailed interface, but I'll show you how to do it here in the wizards. All the underground areas are show up in the green here, and with the allocation that we set on the previous screen, it's saying that 76.3% of this basement floor is office. None of it's conference room, 15.8% is corridor, and so on. Well, I want to make it all storage. So I'll change the percent storage to 100%. Then all the other values change to 0. Oh, that's for the underfloor areas. Now, these spaces are all conditioned. That's right. And the HVAC system, we will have a different HVAC system for the basement since it's all storage. It'll just be heating only. But the way it is right now, we only have the one HVAC system entered into the program. So we'll just leave it as it is, and we just have to remember to come back and reassign this when we get to that point. The zone group details just gives you a choice to put an exhaust fan in there. We won't do that for now. We'll leave that out. Now, the zone group names that we have here will not carry over to the detailed interface. If I click on ground floor, then it shows these spaces on the ground floor. And notice that the allotment for each of the types is different for the ground floor. If we click on the typical floor, see it changes again. There's no lobby, no storage. And on the top floor, it's adjusted a little bit differently. But we want to create some different zone groups. So click on Create Zone Group, and it gives us this screen here. The name I want to give it is No Ventilation. So no ventilation. Parent component, office tower is fine, and copy data from top floor, that's fine. So we're going to change that anyway. You want that to be 100% storage. So 100% there. And notice the other values didn't automatically change, so I'll have to manually make those 0. And again, you have to click twice to get it to change into the field. Okay, so no ventilation, 100% storage. Conditioned, HVAC system, there's only one choice available. And within this space, we'll have the main vestibule, which is this space on the ground floor. So we'll click on the vestibule right here and say, assign zone to active group. And so now that space is in this zone group, no ventilation, that we just created. And we also want to do that for the stairs. So I'll click on the stair tower right here, assign zone to active group. Now, when the spaces get pretty small and it's hard to click in there, you can click on the button above the diagram here, like for ground floor. It just gives you a larger picture of what you're looking at down below. So it gives you a bigger target to shoot at. So I'll click on that, assign to active zone, go done. Middle and above, active zone, active zone. Okay, let's create another one. Click on Create Zone Group, and we'll get a similar screen. We're going to have a lot of these. This is going to get kind of old. We'll call it Perimeter Office Area. Perimeter Office Area, copy from that, office tower. Let's copy data from the ground floor. Click OK. And for these perimeter spaces, I want it to be 20% conference room. So I'll type 20 under conference room, and then the rest, 80%, is open office area. So these others, I need to make 0. 0. Okay, so that all adds up. The HVAC system is going to be the HVAC system 1. And for perimeter office area, I want this one, this one, this one, this one, and this one on the ground floor. Same thing on the middle floor. Select zone to active group. Same on the top floor. Okay, those are all the zones that we need for the perimeter office areas. That was so much fun. Let's do it again. Create zone group. We'll call this one core office area. And we want that to be 70% office area. 20% conference room's okay, but 10% corridor. Enter 10 for that. HVAC system 1 is fine. And we want this core, and the core of the top floor. Those are all assigned to this core office space. Let's do it again. Create zone group, lobby. Call this the lobby. Click OK. And the space for that is on the ground floor, right here by the front door. So assign zone to active group. Now, for no ventilation, I also want to add all the rest of the basement space. So I'll do that zone, do that zone, that zone, that zone. Okay, that's good. Perimeter office area is those, core office is those, the lobby is that, and I have a couple left. Let's see. In the top floor, we have this space right here, and since the active zone that I have now is lobby, you see lobby, I don't want to make it part of the lobby, I want to do it something else. So I can do it through this way here, assign zone to other group, and I'll put that on perimeter office area. So I'll click done, and I can do the same thing with that similar space on the middle floors. Assign to other perimeter office. That's done. Okay, so now there shouldn't be anything left in underground areas, ground floor, typical floor, or top floor. One other thing I want to show you on this screen before we move on is that if you right-click on one of these fields and click on Item Help, topic does not exist. Contact your vendor for an updated help file. There are some fields here in Equest where they don't have the help screens developed yet, which can be frustrating. Let's move on to the next screen. This is where you can enter information for all sorts of different internal loads. And you'll notice that when you look at the different screens available, after this there's a screens 16, 17, but no 18 or 19. There's a 20, not a 21 or a 22, not a 24. Well, if we check the boxes in here, then some of those screens will become available. These are the different interior end uses and have exterior lighting, remote refrigeration, and domestic hot water. Let's check all of these boxes. Basically what we're doing here is just enabling these screens that come after this so that you can enter information for each one of these. The self-contained refrigeration would be like for a refrigerator in the break room or a vending machine. something that's self-contained. It has the condenser on the unit itself. It's not sitting outside somewhere. If it's sitting outside, then we're looking at remote refrigeration. This one down here. Within the SD wizard, you don't have as many choices here. They're all lumped together a lot more. This breakout allows different schedules. You can have a different schedule for task lighting than you can with ambient lighting. And you can have a different schedule for the computers in the office than the refrigerator in the break room. Because hopefully the computers are off overnight, but the refrigerator is still going to keep on running. And you may want to have a different schedule for that. Now, all of the entries that we make here in the wizard are on a per square foot basis. Now, if you don't have the per square foot values for each of these areas, don't worry about it too much. If you have the actual absolute value, you can enter that when you get into the detailed interface. But here in the wizard, just enter something so that it gets in there. And then later on, when you get into the detailed interface, you can change the number to the actual value that you have and not have to worry about calculating it on a per square foot basis. The first of these screens is interior lighting loads and profiles. If you right-click on the space and click Item Help, this is another example where there's no help available. But let's change the lighting power density for the office to 1.1 watt a square foot, and no task lighting. For the conference room, make it 1.3. For the corridor, 0.5. Lobby, 1.3. And storage, 0.8. These values come from ASHRAE 90.1, the 2007 edition. Now, you can enter multipliers for these. We'll just keep it 1. Next, we want to take a look at the lighting profiles. If you click on the button with the 3 dots on the far right, this is very similar to what we saw for the people profiles. There's a little bit overnight. It comes up to a maximum during the day and tails off again in the evening. And again, you can adjust the minimum and maximum, just like we showed before. You can also change the starting point and ending point at the end of the day by putting plus or minus the number of hours that you want to shift in there. And again, this line in the background is the line for the other season. We're taking a look at season 1 now. The background line is for season 2. And this is for Monday. Click on Tuesday, Wednesday, and so on. This is just like the lighting profile that we looked at earlier. Okay, let's click on Done to get out of that. There's a similar schedule for task lighting. You click on the button with the 3 dots. This assumes that people turn off some of their task lighting when they go out for lunch. On to the next screen. This is for the office equipment loads. And again, this is in watts per square foot. For the office, let's have it 1 watt a square foot. And let's put a little bit on our conference room too. Let's make that 0.5 and keep it 0 for the other spaces. And again, we could take a look at the schedule profiles by clicking on the square with the 3 dots. This is the miscellaneous load profiles. Mostly off at night, but some off. Some is still on overnight. And we got people turning off computers a little bit while they're going out to lunch. It's not 100%, just staying at 90%. And again, you can change these for the days of the week too. So for office equipment loads, the next one is cooking loads and profiles. And here we not only have electricity available as an option, but you also have natural gas, so that you can account for a gas-fired stove. We'll leave these zeros in here. Yep, we'll just leave these zeros. You can take a look at the schedule profile. You can see there's a bit of a peak at meal times. A little bit for breakfast, quite a bit for lunch, and some throughout the day for snacking. Then it trails off in the evening. Next screen, self-contained refrigeration loads and profiles. So this would be like the refrigerator in the break room kind of thing, or a vending machine. Let's say that we have a vending machine in the lobby. So let's make that 1 watt a square foot. And when we get into the detailed interface, you can enter the actual wattage of the machines that you have in there. But I like to get the 1 in here just so that we get the schedule set up. And take a look at the schedule. You notice that it doesn't shut down overnight as much as the other miscellaneous loads. Okay, on to the next screen, screen 20. This is for miscellaneous loads. It's basically things that aren't covered with the other loads that we've already looked at. Let's keep these loads in here as they are. Now, this could be something like electric heaters underneath the desk. And again, you can look at the schedules. Quite a bit of use during the day, and a fair amount of use overnight. But of course, that can be adjusted too. This next screen is for process loads and profiles. Again, you can enter the watts per square foot, and you can also enter what fraction of it is sensible versus latent. On the process loads, you may have moisture that's given off to the space. The load can be electric or gas, or it could simply be a process load, and it's not consuming an electrical fuel or electric or fuel. And again, you can see the schedules. A little dip in the middle of the day and some overnight. And of course, these are adjustable. On to the next screen, motors and air compressor loads. I can enter the watts per square foot for the different types, how much of it's sensible, and for air compressors. And again, you have the schedules, very similar to what we've seen in the other screens. Exterior lighting. This has a field where you can enter the exterior lighting on a watts per square foot basis. Again, because everything in the wizard on these screens is entered on a per square foot basis. And the square footage here is the area of the building. It's not the area of the parking lot or area of the exterior walls. It's the floor area of the building. Now, what I sometimes do is just enter a number in here. Then when I get into the detailed interface, enter the actual value. But a fairly decent number to enter here is 0.05 watts per square foot. And the schedules here are for the different months of the year, because they're based on the amount of daylight for those particular months, because that changes throughout the year. Then onto the next screen, this is for the refrigeration loads. These can change from month to month, and you can also have a different schedule for these from month to month. We'll go on to the next screen for the domestic hot water. This is where you can change the load profiles for the domestic hot water. The actual information for the domestic hot water system is in a different button, a different module. But they put the schedule in here with the shell, because that's where a lot of the other schedules are. So that's the last screen for the shell component. There's a lot in here. It took a while to get through, but we're done with this component for the shell. So you can click on Return to Navigator, and let's click on Finish. And we'll take a look at our building one more time just to make sure that it's what we expect. 3D view. Got some windows and doors in there. You see the zoning on the top, the matches. Looks good. Okay, let's get back into the wizard. Save it, yes. Warning, okay. Now before we get into the second shell, I like to get into the HVAC systems and get those defined. So let's double click on HVAC system, and let's call this Office VAV. We'll change the name to Office VAV. Now for the cooling source, there are different choices here. You have no cooling, DX cooling coils, chilled water coils, or evaporative cooling. We'll keep it at chilled water. Then for the heating source, you have no heating, electric resistance heating, or hot water coils. And we'll keep it as hot water. Now, the hot water source is the hot water loop. Now, there's a choice here that you could also pull it off the domestic hot water system, but we'll keep it on the regular hot water system with the boiler. System type. There's the standard VAV with reheat, or we can do fan-powered boxes, single zone. Now, the choices that are available here are limited by the building type that we selected really early on. So if you find that the system that you want isn't listed here, you may need to select a different building type. And unfortunately, that means you might have to start all over with some of the things that you've done. If your VAV system has any fan-powered boxes, you should select a system here with fan-powered boxes, whether it's series or parallel. Because when we get into the detailed interface, you can change the box type from a fan-powered box to a standard type, but you can't change it from a standard type to a fan-powered box. So let's select it with a parallel fan-powered boxes with hot water reheat. The system per area, you have choices here. You can do a system per zone, which isn't very appropriate for VAV. You do a system per floor, system per shell, or system per site. The site would be multiple shells, all the shells together on one system. Let's do system per shell on here. Return air path, choices are a direct return in the room, ducted back to the unit, or a plenum. Since we have fan power boxes, we'll make that plenum. The component's name prefix, S1 is for system 1. This just helps to differentiate it from the other systems. We'll leave that in there, or you could do a suffix instead. And similar to the shell, the total number of characters that you have in here can be 4. You can have like 3 of one and 1 of another, or any combination so that there's no more than 4 characters. You can check prevent duplicate model components. I like to leave it unchecked so that everything's there and there's nothing hiding underneath something else that you might not recognize. System assignment to thermal zones. This is kind of similar to what we were doing with the zone definitions, but this way is not quite as reliable. It has some bugs in it, so I recommend not using this type. On to the next screen. This is where we can enter our thermostat set points. The top part is for actual operational use. The one down below it is for the design day, so that you can take a look at sizing the equipment for a certain indoor temperature, but actually operate it so that the thermostats are set at a different set point. And then airflows down below. We have our two different seasons, the typical use and season 2. So it's like season 2 is our summer. We'll keep these numbers the same. Cool to 76 degrees and heat to 70 degrees when it's occupied. Then when it's unoccupied, it'll cool to 82 and heat to 64. With the design temperatures, we want to do our calculations for being able to cool it to 75 degrees, even though our thermostat set point's at 76. The supply air temperature at 55 degrees, that's pretty common, especially for a VAV system. Heating design temperatures, we'll size the equipment so that it's capable of maintaining 72 degrees, even though our actual thermostat set point is going to be 70 degrees. And for the supply air temperature, 95 seems a little low to me. Let's bump that up to 120. And for airflows, minimum design flow of 0.5. Let's knock that down to 0.4 so that it's more in line with what was in ASHRAE standards a while back. And change the VAV minimum flow to 30% for both core and perimeter. So that's it for our temperatures and airflows. Now we'll move on to the next screen, where we enter information about the fans. First is the supply fan. Now, you can either enter the pressure that the supply fan sees, or we can actually enter the brake horsepower. We'll keep it as pressure. Now, the pressure here is the total pressure. It's not just the external duct pressure drop that's outside the unit. It also takes into account the pressure drop through all the components within the unit, the filters, the cooling coil, heating coil, and so on. It's the total pressure that the fan sees. So let's bump that up to 5 inches. Motor efficiency, for new construction, you have to go with premium efficiency now. It's a new federal standard. And for the safety factor and outside airflow, you click on this button here and we get this other screen. You can either auto-size the airflow or you can specify. If you're trying to match an exact design and you know exactly how many CFM this air handler is going to have, you can enter it here this way. Let's keep it auto-size, but remove the safety factor. Make that a 1. And for the minimum outdoor air sizing method, the choices here are sum of zone outside air and set by critical zone. Since we have a multi-zone system here, a VAV, we want to set by the critical zone, because that's what's required by ASHRAE 62.1. The control method, you can do the fraction of the design, fraction of the hourly flow, so that as the flow changes, the outside airflow will actually change. Now, many old VAV systems were designed that way, so that's why this option is in here. And there are also a couple options for the demand control ventilation. We'll keep it on fractional design flow, and click Done. Now, with the return fan, you can have it either be in the return fan configuration or as a relief fan. We'll keep it as a return, but bump the static pressure up to 2 inches. And again, a premium efficiency motor. Let it auto size and variable speed drive. Some other options in here are to use inlet vanes, discharge dampers, or vane axial. That's it for system fans. Oh, one other thing to point out here, though, is that the fan curve for the variable speed drive that's used in Equest is based on a quadratic curve. If you're doing a lead model or one that has to follow the rules in Appendix G, you need to use a fan curve that's based on a cubic. So you'll have to create a custom fan curve for the VAV system if you're doing a lead model. That's more detailed than what we want to get into now, but it's something to be aware of. The next screen, this is the fan schedules. Looks very similar to the occupancy schedules, and in fact, it's based on the occupancy schedules. It starts an hour before the regular occupancy, and it shuts off an hour after the close. Now, this can account for the early birds and stragglers, or for the cleaning staff in the building. But those can be adjusted, or you could select it so that the fan is on all the time, or off all the time, or is on from some other times. Now, you also want to be able to cycle the fans at night in most cases. Equest, unfortunately, in my opinion, has a default value of no cycling at night. And if you don't change this, you can see a lot of unmet load hours in your results. Because what happens is the fans simply don't come on at night. And so the temperature drifts as the night goes on. And then when morning comes, the fans suddenly kick on, and it takes a long time for it to keep up, or to catch up. So you may have a lot of unmet load hours, not only from the hours during the night when the system wasn't allowed to come on, but also that morning period where it's trying to catch up. So for this system, let's select cycle fans with no outside air at night, but allow an economizer. Now, when we select that, we've got this other field that comes up that says cycle fans on via a particular zone or any zone. If any zone needs cooling or heating, then turn on the fan, or only if a particular zone needs it. Let's keep that on any zone. Move on to the next screen. If the system has any baseboard heaters, you can add that here. It can either be hot water or electric. Let's do some hot water. Now, the value that shows up here is just a guess that Equest comes up with. If you want the system to auto size the capacity of the heater, then you need to make this 0. So let's click enter 0. And it's from the hot water loop. Delta T of 30 degrees is fine. So that's it for our baseboards. For economizers, we have a few options here. It can be based on the dry bulb temperature. It can be based on the enthalpy of the outside air. Or the dual temperature is differential temperature. It compares the temperature of the outside air to the temperature of the return air. And dual enthalpy is pretty similar to that, except it takes a look at the enthalpy and accounts for the humidity. Let's keep it at dry bulb temperature and change the high limit to 70 degrees. Now, one thing that you notice in here is that there's no low limit on here. When we get into the detailed interface, we'll see that there is actually a low limit assigned here, but you can't change it here in the wizards. It's something that you can only change when you get into the detailed interface. And the limit for a lot of these systems is at 45 degrees. So what that means is when it gets colder than 45 degrees outside, the economizer will shut off, and it'll turn on the mechanical cooling if cooling is needed. So you may see some chiller runtime in the winter, and that's because of this low limit on the economizer. Once you get into the detailed interface, you can drop that down, and then that chiller runtime in the winter should go away. One more screen here is for the temperature reset of the discharge air temperature coming out of the unit. Now, there are different options here. You can take a look at the warmest room, the one that needs the most cooling, and reset the temperature based on that. Or you can base it on the outside air temperature, which is the schedule that you see here. So that when the temperature outside is 80 degrees or warmer, the discharge air temperature is 55 degrees. And when it's 60 degrees outside or colder, then the discharge air temperature is 65 degrees. And for temperatures in between 60 and 80, it's a linear relationship. The other option is constant. Just keep it the same. Don't change it based on the warmest room or on the outside air temperature. Let's go back to outside air reset. And let's change these temperatures from 80 to 70 degrees and from 60 to 50 degrees. Yep, so that's it for our HVAC system. So return to Navigator. Now let's create another HVAC type for those storage rooms in the basement. So click on Create New System, and we'll call that Basement Heaters. Copy data from None, because this is going to be unique. We don't want to copy from the VAV system. So keep that None. Click OK. Now, for cooling, select No Cooling. For heating, we want hot water coils. Put that on the hot water loop. Hot water furnace with zone ventilation. No, let's change that to hot water furnace with no zone ventilation. System per shell. No, let's do system per zone, so that each of those sections in the basement will have its own little heater. Notice that the prefix now is S2, for it's the second HVAC system that we have entered here. We'll just leave that alone. That's fine. Now we'll move on to the next screen with the thermostat settings. Since this is unoccupied storage areas, we'll make it just 65 degrees year-round. We'll change that to 65. Well, that was already 65. Keep it here, 65 and 65. Since we don't have any cooling, it doesn't matter what the cooling numbers are. For supply air temperature, again, let's bump that up to 120. And minimum design flow, we're just going to have little propeller fans on these unit heaters, so we're not going to have very much airflow. Let's set that to 0. It will take as little as we can get. On to the next screen. This is our fan energy for these little unit heaters. Let's enter a value of 0.2 inches. And for our safety factor, let's drop that down to 1. Done. And for the motor efficiency, make that premium. And we're all set with the fans. Fan schedule. Since we just want it to cycle whenever there's a load, there's not any particular occupancy down in these unoccupied rooms. So I want to set it up so that it's off during the entire day. Except I want the fans to cycle whenever there's a load. So essentially what we're doing here is saying that night is all day long. And so the fans will cycle on whenever it's nighttime, whenever there's a load. So I'll pick off for each of these. And we're all set with the fan schedule. Next screen, any baseboards? No, not in this particular case. And that's it for our basement heaters. So we'll return to the navigator. I'm going to go back and check something. Yep, that was good. Okay. Now that we have our basement heaters created, we can assign that system to those zones. So let's go back into our office tower and select the screen 14, where we did the zone group definitions. With the no ventilation, I want that to be on the basement heaters system. That's all we need to do here. So let's go back to the navigator. Next, let's create another system, the HVAC system for the warehouse part of the building. So again, click on Create New System, and we'll call this Warehouse RTU for rooftop unit. Copy data from nothing because it's unique. For the cooling source, that'll be DX cooling. And the heating source will be a furnace. For the system type, I don't want a multi-zone. I want a package single zone. Package single zone DX with furnace, not a residential. That'll be our package rooftop unit. The system per zone will be fine because we'll have just one zone in there. And ducted is fine. And our prefix is S3. That's fine. We won't define the zones yet. Actually, those zones haven't been created yet. We're going to make it easier later on by creating this HVAC system first. On to the next screen. This gets into our temperature settings. We'll keep these default values. They look pretty good. On to the next screen. Now for the fans, let's auto size it. Now, the size range here is for it to estimate the cooling efficiency, because in the codes the cooling efficiency is dependent on the capacity of the unit. Let's guess that it's in this range here, about 20 tons. The condenser type is air cooled, and so the EER about 8.5. Let's actually make that 10. Allow crankcase heating. That looks fine. For the heating, it's also auto size. And let's make that an even 80% for the efficiency. Okay, so that's our cooling and heating systems. Under the next screen is the fans. Again, you can enter the static pressure or the horsepower. We'll keep it static pressure for now, but let's bump up the static pressure to 3 inches with the premium efficiency motor. And to auto size, but with a safety factor of just 1. Some zone outside air is going to be fine because we'll have only 1 zone. And minimum control method, the fraction of the design is appropriate. So pick that, go done. On to the next screen. This is our fan schedules. And we'll keep this to pretty much match the occupancy schedule, but I want the fans to cycle at night, and we'll also have an economizer. So I'll make that selection. Okay. When the fan is on, I want it to stay on continuously. That looks good. Moving on to the next screen. Any baseboards in the warehouse? No. For economizer, let's keep it dry bulb. Again, it's the same choices that we saw with the VAV system, but we'll bump up the temperature to 70 degrees. But then, since we have a DX system, we also have the choice of being able to run the compressor while economizing at the same time, to do a partial economizer. Cannot run with economizer is all or nothing. It's either all economizer or it's off and you're just running the compressor. Let's set it up so that we can run the compressor with the economizer too, so that we can take advantage of some economizing. And return to Navigator. That's it for our packaged rooftop unit for the warehouse. Now we'll create our second shell, that warehouse. So click on Create New Shell, and we'll call it Warehouse. We could copy data from the office tower if we wanted to, but let's do none. This is going to be rather unique, so we're not going to create. We're not going to copy so much from there. So click OK, and I want to change the building type to storage conditioned high bay. And this is going to change a lot of our default values now. It'll set our default values. Now, the next part here is the shell location. Where do we locate this shell compared to the previous shell? You can either do it relative to some other shell. You can do it immediately above, immediately below, or some direction, or via coordinates from some other shell. We only have one other shell in here, the office tower. But what I prefer to do is to specify exact coordinates. So I check the box here, and I make sure that I start at 0, 0, 0. I make these all 0. Now for the building area, we'll knock that down to 100,000 square feet. 1 floor above grade, 0. 1 above grade, 0 below grade. Shell multiplier 1 is fine. Daylighting controls, change that to yes. And a prefix of L2 is fine. Okay, on to the next screen. This is where we can create the outline of this. Create custom again. Do blank slate. Use the CAD file. This is the previous one that we had before. We'll click OK, and we're in here. I just want to check the settings here. Sure it's going to snap on the CAD. Let's change the grid resolution to 20 feet. The snap ranges to about 2 feet. Snap to the CAD first, but not to any of these other things. So go no snap, no snap. Done. Okay. Now, click on the arrow so that we can start drawing our dots. Click on here. For the next one, get it out to this corner, and up to that corner, and up to that corner. Again, we have to go clockwise. Counterclockwise. And since we have this CAD drawing in the background, you can see the first shell that we did, that office tower. And by tracing it this way relative to the office tower, it's going to put this shell right where we want it. Click OK. Save this. Yes. Zoning pattern. Let's just do one per floor. This will all just be one big zone. For the floor heights, I don't change that to 25. But I'll show you, if I change the floor to floor height to 25, while the floor to ceiling height is 45, we'll get an error message. But we'll just have to change this to 25 here. And then we'll put a pitched roof on this. Not much of a pitch, but just to illustrate how you can do a pitched roof in Equest. There are different choices for the insulation location. You can have it on the attic floor or the roof surface or both. Let's put it on the roof surface. Not pitch it quite so much, not 25 degrees. Let's knock that down to just 5 degrees. And have it overhang about 4 feet. Now, we can change the ends on here so that it's not a hip roof. You can change it to gable by clicking on the red mark on the side. See how those lines go away? And now we have a gable projection out there. And the amount of that gable projection is 4 feet. We can change that to, say, 3 feet. And we can also change adjust this by clicking on the custom footprint. Because you'll notice that the roof sticks out 4 feet over the adjacent building. You can't have that. So we want to move these vertices here. So we got this one. I think it's going to be easier just to change the number in the table over here. Instead of 96, it's going to be 100. And at this point over here, instead of 96, I want to make that 100. And I click on some other field. Now our roof is no longer bumping into the adjacent building. So we'll click Done and save it. And done here. Now, one thing you notice here is that this wall in the diagram down below is dashed. If you right-click on that, you'll see that it's now partially adiabatic. That's because part of this wall is adjacent to the wall in the other shell. When you put these two shells together and they're right up against each other, Equest knows to change the walls in the contact area in both of the shells to adiabatic. Now, this only works for walls. If you stack shells on top of each other, the same feature is not available for changing roofs and floors to adiabatic. That needs to be done manually. Okay, that's it for our building footprint. We're all set. Go on to the next screen. And for our roof construction, let's use the same type of roof construction that we had before. And we can do that by custom layer by layer and select the roof construction. This is exactly what we created in the earlier shell. For the walls, we'll make that different. Let's make this masonry, or let's say we got 10-inch concrete tilt-up panels. So the exterior finish is concrete. It's medium. We'll have some insulation in here. Let's put it on the inside. Not furred, though. Let's put okay. I'll go back and redo the wall stuff. For the wall of the warehouse, let's make it a concrete wall. Select 10-inch heavyweight concrete, and then let's add some insulation to it. Say we have some EFS, 2 inches of polyisocyanurate. So that's our insulation. For the ground, we're in contact with the earth. The slab, let's change that to just a 6-inch slab instead of 12-inch. And for the interior finish, let's just keep it no surface finish. There's not going to be any carpet or anything in there. For the perimeter insulation, let's select vertical, exterior board, R10 going down 4 feet. Then for the infiltration, just like in the other shell, let's make that 0.15 CFM per square foot. And done. That's it for the building envelope construction. So now we'll move on to the next screen, which is the interior construction. The interior finish below the attic. Let's make that drywall finish with metal stud framing. No additional insulation there. We got the insulation on the roof. And for the ceilings, just no ceiling at all. So we'll select none. That's it for our building interiors. Under the next screen for our doors, let's have an overhead door and an opaque door, and get rid of this other opaque door by clicking on Select Another. So that goes away. For overhead door, let's just have one on the east and the west, and none on the north or the south. For the smaller doors, let's not put any on the south. Let's just have one on the north and none on the east or west. Okay, the overhead doors are 10 by 10, insulated steel with a break. And the 7-foot by 3-foot door, let's make that insulated, a polyurethane core with a break. That's it for our doors. Now we're on to the next screen for the windows. Here for the windows in this shell, let's make the window width 10 feet and a height of 5 feet. Sill height, put them up fairly high. The south end has the building office tower next to it, so there won't be very much window there. Let's just make that 5%. On the north side, let's make it 10%. The east, 10%, and the west, 10%. Then, let's take a look at the 3D view, see what we got there. Okay, take a look at the 3D view. Okay, so we got a window there, up high. We got some windows up high on the east side, and on the north side, and on the west side. And go back to the wizard. Yes. Warning. Okay. Back to the shell. And I want to go back to that sloped roof and get rid of that because we want to put some skylights in here. And one of the limitations of Equest is you can't put skylights in a sloped roof. So I'll take this out and we'll move on to the next screens. Here's our interior constructions, exterior doors, our windows. Shades, we won't have any shades on this part of the building. Okay, skylights. Roof skylights, let's put it all. This diagram shows where it's putting the skylights based on these default values. Let's change the percent coverage from 3.5 up to 4%. The skylight size, 4 by 4, is fine. Notice that the number of skylights changed. It's now up to 50. And we can change the type of skylight. There are some library types available, or you could specify properties. Let's specify the properties. Notice that the button changes. That's very similar to the windows and the glazed doors that we looked at earlier. So you click on the button. Once again, you have a choice between the U value or the U factor method. Let's do the U value. That's the glass type. And we'll have a U value of 0.9, shading coefficient of 0.71, and the visible transmittance we'll leave at 0.52. So we're done there. Light well depth, let's make it a little deeper so that we can account for some more snow accumulation on the roof. Let's make it 2 feet. Diffused glazing and domed on top. The inside reflectance of the light well, 70% is fine. Now, one of the new features in the latest version of Equest is this custom skylight. You can check this button here, then you can edit custom skylights. But there have been some bugs with this, and I haven't used it because of that. I would just be aware that it's there. And hopefully it'll work better in future versions of Equest. So that's it for skylights. Let's move on to the next screen. This is for daylighting. We want to do daylighting from all the skylights and the windows. Again, the method here is fine. Find the light level. Let's make it 30-foot candles. And for the control type, let's do switched, full, 2/3, 1/3 off. It's 3 steps. On to the next screen. This is the building operation. 8 to 5 for both seasons. For season 2, we can make that low use again, just like we did in the other shell. Now for the activity areas, we'll just have it all be storage. So we'll get rid of these other types. I select another, scroll up to the top, select another. Here, scroll up to the type, select another. Okay, so all gone. Change the percentage to 100. As far as the people density, that looks fine. CFM per person, let's knock that down to 15. Okay, and take a look at the occupancy profiles. That looks fine for now. On to the next screen. Storage, 100%. Okay, I want to change the HVAC system to this packaged rooftop unit that we created. So that's done. On to the next screen. We'll have interior lighting, but we're not going to have office equipment, no cooking equipment. Let's get rid of the miscellaneous equipment. We're already taking care of exterior lighting and domestic hot water in the other shell, so we can uncheck that. So all we're left with is interior lighting. So you notice that we just have one more screen left, interior lighting. Let's go there, and let's make that light level 1 watt a square foot. So we're done with that. Return to Navigator. Click Finish. And take a look at the 3D view again. We've got our skylights in there. Got windows, doors. It's looking good. Except we need to go back to the earlier shell so that we can change some of these custom windows. So I'll go back into the wizard, save the changes, yes. Warning, okay. Get back into the shell for Office Tower. Double click on that. And we want to go to the screen for the windows, custom the exterior windows, screen 6. Then we'll go into the custom window and door placement. You know, here's that warning again. If we make any changes to the zone footprint, whatever changes we make here will get wiped out. So that's one of the reasons why I waited until we had this other shell done, just in case we needed to tweak something in the floor plate. So it's okay. Get into here now. Let's click on this glass door here and delete it. Then let's make this window bigger. First, let's move it over to the left a little bit. Instead of having an X value of 49, let's change that to 35. We'll shift over, and we'll change the width to 20 feet. Okay. Now let's add the glass door to this part here. I don't want this to be a window, so I'll delete the selected door window. Delete it, yes. Now we want to put a door in this part here. So we're going to create new door window. Now, even though it's a glazed door, it's not really a door in here. We still have to select it as a window. So select window. And for the X coordinate, let's put it over 5 feet. We want it to be down at the ground level, so Y is going to be 0. Width of 6 feet, height of 7 feet, frame width 1.3 inches. And for the glass type, we'll do that very first one. And click OK. There's our entry door. So we're done. Return to Navigator. Finish. All right, then take a look at the 3D geometry. And we've got these adjusted windows now. Okay, let's get back into the wizard. And we'll take a look at the information for the chilled water plant. So click on the button for a chilled water plant. There are only 3 screens here. There's one for the chiller, the cooling tower, and then some controls. So starting with the chiller, the head for the pump here is the total head. It includes going through all the coils and the air handlers, the pipes and fittings, and so on. So let's change that to 60 feet. The design delta T of 12 feet. And for the pump configuration, let's select it so that we have a primary secondary pumping arrangement. So we have both system and chiller pumps. The number of system pumps, now, we might actually have 2 in place, but one is a total backup. And in the energy model, you just want to have the number of pumps that will be operating at a particular time. So if one of your pumps is a total standby, and it's going to be one pump or the other, and only one pump is going to be running, then you want to keep the number of pumps as 1 in here. You don't include a redundant spare. The loop flow is going to be variable. Again, this is for the secondary loop that goes out to the building. The pump control, a single speed would have the operational point ride the pump curve. But we actually want to control it with a variable speed drive, so we select VSD. Motor efficiency would be premium. Now, these numbers for the loop pump, head and feet, we'll just leave those blank so that the program will auto-size those. This line in the middle to estimate the cooling capacity here is just an aid to select the capacity of the chiller, which will determine the default value for the chiller efficiency. Since I know what chiller efficiency I want to use, I don't really need to pay attention to that now. But for the first chiller, let's leave it a screw type. Select a screw chiller. Make it water-cooled. Chiller counts. Let's have just one chiller here, and its efficiency is going to be a COP of 4.5. The pump efficiency, and that'll be premium, and we'll keep that single speed. Now for our second chiller, we'll also make that a screw, and kind of change this just back to water cooled. This water cooled, and I changed my numbers for the COP. We'll go 4.5, and change this to a COP of 4.5 also. Again, premium efficiency motor, single speed. Okay, so that's the information for our chillers and for our pumps. You can go on to the next screen, where we enter information about the cooling tower. For the condenser water pump head, let's change that to 60 feet, and a delta T of 15 degrees. For the pump head and flow, again, we'll leave those blank so that the program will auto-size that. For the type of cooling tower, there's a choice of open tower or an open tower with a heat exchanger, a dry cooler, or a fluid cooler. Let's select an open tower. At temperature control, do fixed or reset. We'll keep it at fixed and 85 degrees. Keep it simple. And for the capacity control, we'll do a 2-speed fan. It's high efficiency, but propeller. So that's our cooling tower definition. Now we'll move on to the schedule. The choices for the set point are to have it fixed, reset by the load, or reset by the outside air temperature. Let's keep it with load reset, and then the temperature will vary between, let's make it 45 degrees and 55 degrees. The operation choices here are standby, scheduled, and demand. Standby will run the pump if any fan is on in any system. Scheduled, the pump will run whenever the schedule down below says it should run. Or demand means the pump will run whenever there's a cooling load. So let's select demand for that. And it's going to ignore the schedule down below because we didn't select schedule. All right, that's it for our chilled water system. So we'll return to the navigator. Now let's take a look at the hot water plant. Click on the button for hot water. And again, we'll change the system head to 50 feet and the design delta T of 30 degrees. The pump configuration, again, let's do primary, secondary. So both systems and boiler pumps. Just one system pump, but it'll be variable speed and controlled by a variable speed drive. Leave these blank to auto size. With motor efficiency, jump up to premium. And for the boilers, you can leave that natural draft. Have two of them with 80% efficiency. This pump have a premium efficiency motor and single speed. It's very similar to the chilled water plant. It's just that we have boilers instead of chillers. Onto the next screen. This is very similar to the one for chilled water plant for control and schedule. For the set point, you can have it be fixed, reset it with the load, or reset based on the outside air. Let's select outside air reset. And if you look at the help screen, say the hottest temperature here is for an outside air temperature of 30 degrees. And the minimum temperature here is for when the temperature is 65 degrees outside. Okay. We'll keep it at 180 and 140. Because we don't want to get too cold because we have a non-condensing boiler here. As far as operation, this is the same as what we saw for the chilled water system. Standby, whenever a fan is on, the pumps will be on. Scheduled, whenever the schedule defined down below says that the pumps should be on, then they'll be on. Or we can do it based on demand. So we'll select demand. And that's it for our hot water system. Click on Return to Navigator. And one last plant we'll take a look at here, the domestic hot water. So click on DHW Equipment to get into the domestic hot water. Real quickly here, the fuel choices are natural gas or electricity. The type, you can do storage or instantaneous. And for storage, you can enter values for the gallons per person per day, input rating of kBTUs. Now, the default values here are from the ASHRAE Fundamentals Handbook. The efficiency can be defined either the efficiency and standby loss, or you can do the energy factor. Let's do an energy factor of 0.63. With a storage tank, you can enter the capacity. Let's make it an even 500-gallon tank. Insulation R value of R12, that's fine. Water temperature of 135. Let's bump that up to 140. Inlet equals ground temperature, or you can specify a constant temperature for that. Recirculation, the percentage here is how much of the water that leaves the water heater gets recirculated back. So let's enter a value of 5%. Then I click on one of the other fields to get some other fields to show up here for the pump. The motor efficiency, we'll make that premium. And for a head, let's keep that 0.5. That's it for our domestic hot water plant. We've entered all the values now. Let's click Finish, and we'll run it. See what happens. Okay, I think that's a good place to stop.